Thanks a lot. So, good morning. This is my monthly seminar for Fred Inc. And we're going to be talking today about AI product development and deployment. So, a couple, this is sort of an impromptu, extemporaneous type of talk. And I'll do some editorials. So, let me sort of preempt the talk by offering a couple words of caution. First of all, I'm going to be dealing with topics that a lot of speakers don't want to address. Religion, politics, race, identity, climate change, even. So if you got any problems, call Fred. You know, he'll have all the answers. Second thing is most talks that you listen to, somebody's going to be talking about success. I'm going to be talking mainly about failure, lessons learned, things what things not to do. Um, this whole world of AI product development is brand new. Few written rules, and a lot of people trying to figure out what to do with it and how to make some money from it. So I'll share some hard lessons learned. The other thing that we're going to do in this talk is do stories. I'm going to offer 3 use cases. 2 failed, and 1 is still in development. But they're use cases of AI product development. And they've got a lot of implications for all of us. The final thing I want to talk about is when we think product development, we think technology. But AI really is a social technical system. And a lot of the product development that you're going to see or do in the future is going to have to deal with the social side, something that engineers are not used to. I'm certainly not used to it. So it's been an interesting journey. The second thing I'm going to talk about, with other caveat I want to talk about is we're going to talk about dynamic systems. Most product development is static. You've got a design, you build a design based on constraints, use cases, stuff like that. When you're doing AI or app development, you're really looking at dynamic systems. And a lot of this talk is going to deal with dynamic product development and deployment. So anyway, if you've got any questions, give Fred a holler. I'm just kidding. You can reach out to me too. So let's dive into it. So this is an important certificate. Starting right after 9/11, we were the first company in the country to actually do risk assurance for the Department of Homeland Security. As a matter of fact, Homeland Security hadn't been stood up by that time. And we were, because we're a professional engineering firm, tasked to do risk analysis of critical infrastructure, nuke plants, chemical plants, water plants, things that, or cybersecurity, things that were early in what I would call this life cycle. And this is an important certificate because right now, the whole AI development or movement is really going to focus on building trust. And another way to say that from an engineering point of view is building assurance. Assurance is a form of trust. And the question with all AI systems right now is, how do you build trust in the systems, especially in these systems that often are not explainable? We don't really understand what's going on under the hood. We don't know what the inputs are, what the process are, and the logic trail, which quite often doesn't exist between the inputs and the outputs. So what we're going to see, and this is being developed right now, are more of these type of certificates. Now, this one here from the Secretary of Homeland Security was for basically critical infrastructure, big buildings, big facilities. But now we're going to see this for AI systems, especially public-facing, autonomous, decision-making, and problem-solving AI systems. So with that said, a little background. I've been doing this a long time, evangelizing that the future quality is risk, and you can see the rest of this stuff. We've been involved in risk, quality, reliability for a long time. So again, we're going to cover 3 case studies or use cases. A lot of this is things that we failed at. So anyway, if you've got questions, reach out, and hopefully we'll have some fun. So in these use cases, we're going to cover these questions. Originally, I was going to cover these questions, what we would call episodically, one after another after another. But what I thought would be a little bit more helpful was to develop stories around quite often the failure in our product development and some lessons learned, some hard lessons learned. So anyway, over the talk, I'm going to cover these topics. What is an AI product? What's the requirements for AI integration? What's the state of AI product development? What are the key questions for almost all AI product development? What's the lens for product dev? And what can we do? What can you do as quality reliability professionals to position yourselves? So anyway, the first 2 use cases I'm going to talk about is the future of work. And a little background. We started this, oh shucks, almost 30 years ago, doing the future of work. And you can see this in some of our books that we've developed. And we've worked with the largest associations from PMI, IEEE, to, just about every large engineering association in North America. So what we do every year is we work with Oregon State University Computer Science Department to basically take a team of their seniors, normally 4 people, and develop a product. And it's a win-win. The students, 4 students, quite often, who are seniors. Now, every senior at Oregon State has to have a project. Normally, an computer science project can be an IoT, Internet of Things. It can be a software, it can be an app. Anyway, they need a project, and we sponsor them as a company. And this is our now 4th year, coming up to our 4th year in developing projects. The students get experience. They have a story to tell for employers. We basically test out ideas. And it's worked out really well. So just to give you an idea, CS programs now, they're graduates, like University of Washington, on average are making $110,000 a year. Top graduates, about $170,000. Oregon State University is certainly not a Carnegie Mellon or an MIT Stanford CS, but it's a very strong land-grant school. Largest one, as a matter of fact, they have the largest CS program, computer science program, in North America. Very strong program, very practical, and hard to get into and hard to graduate. So we work with them and we sponsor, 4 of these seniors to develop products. And a lot of our lessons learned are the products that we've developed them. So about 2-3 years ago, this is our first use case. It was a future work app. And I can go through some of the pain points here. The pain point is OSU students didn't know much about work. The system we were developing, AI system, was going to be dynamic. It was a future of work. And we're going to basically use APIs to hook up to federal resources. For example, an API, just think of an API as just simply a electronic hook to access resources, access data from a database. An API, and by the way, that year, about 3 years ago, every company wanted to be an API first company. So this was a hot topic. And we were basically going to develop chatbots and APIs to federal resources. One of which was on the Future Work app was BLS, Bureau of Labor Statistics. They have a number of endpoints, API endpoints, and we hook up into them and we pull data to them. We pull data into our app, and students at OSU can basically use that to see how much did graduates make, what parts, what jobs are really hot, what's the growth in jobs. Anyway, they can get information that they can use to basically understand, where do they want to work, what do they want to specialize in, and do they want to go to grad school. So the actors were OSU students, and what we're going to do is test this app. We did test this app with Oregon State, and then we're going to move it on to other universities. Also, part of our effort at OSU was to work with the Career Center and professors to understand the local job market. So here's the problem that we're trying to solve, and you can see this in our submission form to the electrical engineering and computer science program at Oregon State. The thing on the bottom basically are the pain points that we tried to solve. And as you can see, they're very compelling. They all deal with the fact that the future work, jobs, careers are changing. For example, 1/3 of all graduates are underemployed or unemployed. Anyway, we thought we had very compelling data, and we basically had 4 very, very bright seniors from Oregon State CS program, and we started to develop an app. Long story short, it failed. This is the splash screen of our app. There's some things going on in that app. First of all, in every computer program, what you see is the first opening message is hello world. Well, we wanted to make it hello VUCAN, and VUCAN is an acronym for volatility, uncertainty, complexity, ambiguity, inhabitant. Basically, the idea is we're living in a new world. We got to get ready for uncertainty. So anyway, we built the app. We did a lot of iterations. We had a lot of fun, but it failed. It failed for a lot of reasons. One, if you go back to the previous description, we were much too broad. We thought we could develop a future work app addressing all of these problems. Wrong. We had to basically, and this is one of the things that took us, and by the way, these 4 seniors worked on this project as well as our team for 9 months. Our scope, our use case was much too broad. Second thing is we should have tested this idea with a broader population of students. We tested it and we did surveys with all of their seniors. I think there were about 600 of them that we tested. And so we did surveys, but we didn't get, and by the way, we only conducted 1 survey. We should have done multiple surveys because we asked too many broad brush questions. Another problem we had is we didn't make the actor benefits clear. In other words, what's in it for the student? What's in it for the faculty? What's in it for the Career Center? What's in it for employers? We just didn't have a very clear or compelling argument, benefit. What's in it for them? And the them, by the way, are the stakeholders. Too many stakeholders, and we weren't clear in terms of what the value exchange was. Anyway, we should have gotten more university stakeholders involved. The other thing is we assumed that the students knew more than they did. So this is an important point, and throughout this talk, there are going to be a number of takeaways. When you're developing apps, well, first of all, let me make a sort of an assertion. Almost every product these days, whether it's an electronic product, an IoT, an app, is smart, meaning it has an internet connection, and it's dynamic by definition. And, the example that's quite often used is a car. It's a mechanical device, but it's really a computer on 4 wheels. Every product has an internet connection and has smarts, meaning it's dynamic. schools, EECS, mechanical, chemical programs, they do not teach dynamic design. They explain the tools, but they do not talk about the architecture, state management, a lot of topics. So we assumed that the students coming out of one of the largest school CS program in North America knew latency, knew how to program deeply, knew how to connect to an API, knew how to connect with a chatbot. Wrong. That assumption basically put us back about 4 months because they needed to learn how to do all those things. First of all, they don't teach that in school. So there were a lot of assumptions that we didn't know. Other thing is we should have started out with a clear pain point, and we should have made it fun. Our effort on the right, Hello Wukin, was our effort to make it fun. So we built the product. We had some fun, but there were a lot of lessons learned, almost all of them from failure. So the next year goes by, and we want to have another app, what we would call a future work app. But this time we called it the School to Work Transition App. We took a lot of our lessons learned from the previous year, and we incorporated it into our work package or project package for this year. So the pain point is the students didn't know much about work, and we still had the same problems as the previous year. But the difference is our problem statement was much more narrow. In other words, we wanted to make the project doable. Instead of trying to boil the ocean like we did last year, we basically targeted the app for school to work transition. As you can see, we tried to have some fun with it, and we had 3 key stakeholders, and this is our problem statement. Students who wanted to basically be work ready, employers who could learn how to manage and how to attract Gen Z, and 3 universities, how to make the school to work transition easier for students. And the university had a big stake in it because they wanted, especially their CS program, they wanted to be one of the top 10, top 15 in the country. Right now, I think they're probably in the top 30. But still, they wanted to be in the top 10. So everybody had a big win in making sure, assuring that this project would be a huge success. So here's the pain point. And this was data from a survey that had been run August 2023, just about a year ago, a little bit less than a year ago. And the critical piece was, and this is the problem we were trying to solve, is that 40% of business leaders believe that recent college graduates are unprepared for the workforce. And you could see the reasons below. Now, there are a lot of implications to this. And when we started working on the project, we didn't understand the assumptions, the boundary conditions, the social technical elements of product development and AI. There are a lot of things that we didn't consider. Even though we had a failure, it wasn't an abject failure the previous year, it was still a fail. But this year we got a little bit smarter. And we tried to design this project in terms of a pain point. And here's the pain point. 40% of business leaders don't believe that student grads are prepared. The other thing is 94% admit they avoid hiring Gen Zers. And here's the critical issue. The majority of business leaders think culture, the lack thereof, when they mean culture, that's code word, is to blame. Now, culture from the employer's point of view is identity politics, work ethic, transparency. Anyway, lots of stuff. Whether it's right or wrong, this was our pain. This is what we tried to develop an app to help students migrate to work. And if it worked in the CS department, then we could basically scale it to the rest of the university and to other universities. That was the idea. Also, it could be monetizable, make money. So anyway, this was our assumption. And of course, and by the way, these projects for seniors are called Capstone. And you could see from the top, this is what the students would gain. And this is what, and again, there were wins, WIFMs. What's in it for them, for everybody? The students would gain the stuff on top. Oregon State computer science department would gain the stuff on the bottom. Now, why is that important? Almost every engineering program in North America is ABET accredited. ABET is Accreditation Board for Engineering and Technology. If you're in an engineering program, chances are you're ABET accredited. So everybody had a win. The college had a win in terms of a great story to tell. The seniors had a story. Everybody was going to win. Employers were going to win, even. They were going to get graduates that they needed for basically keeping their lights on, their business going. But the whole thing failed. And it failed for a number of reasons. We didn't talk to employers deeply enough during the app development. What did I mean? Well, a lot of employers at that time, and by the way, this was just when DEI, diversity, equity, and inclusion were becoming very hot. A lot of companies were forced to have these DEI programs. And DEI, I think, is the right thing to do, but they were forced through, oh golly, uh, there's a lot of greenwashing or equivalent going on in this space. And a lot of employers, when you started asking them, why were you not engaged in this app as much as you could have? They said, well, we didn't have the time, we didn't have the money. But when you delved a little bit deeper, in other words, ask the 5 whys, why, why? A lot of it came down to, well, we don't believe in DEI. And by the way, this is before the Supreme Court renunciation of affirmative action. They just simply didn't believe in it. There was a lot of what I would call signaling, virtue signaling, but the reality is they didn't believe in it. And the fact that we were working with Oregon State students who they just simply said all of them are DEI graduates, basically that created a lot of problems. And we really didn't understand at a deep level what employers were looking for and what they wanted. We assumed, and of course we all know what that means, that of course DEI, everybody would get on board. CS graduates were not sort of DEI graduates. They didn't get into the program. It's a very hard program to go to. But again, employers lumped this whole generation almost, at least last year, in terms of this group, and quite frankly said, yep, we would work with you. But the reality is they didn't. And we didn't understand the market well enough. The second thing is AI or app development is really a social technical system. We were developing a product. We were developing a technical product. We really didn't understand the social implications of what we were doing. Now, why is that important? Well, give you an example. When we started, we had the faculty, we had employers, we had a lot of people engaged. Only problem, a lot of it was we really, and they hadn't really thought through the problem, the social piece. Again, we were focusing on the technical use cases, APIs, bring in chat box, bring in experts, make it into a dynamic system, low latency, lots of stuff. But really, the thing that failed this project was the social piece. We really didn't understand the implications. Quite often, the social system is much more important than the technical. And we really didn't understand how AI could support our goal, the problem we were trying to solve. Again, at that point, and this is almost at the same time that GPT just went crazy, or generative systems went crazy. A lot of us didn't understand how to integrate AI into the product development or the app lifecycle. We didn't know the benefits. We didn't know how to, the technology was fairly straightforward, but in terms of the integration, very difficult. Now, large companies are having a hard time justifying the ROI, return on investment, for developing these large LLMs, large language models. So even at a micro case of what we were doing, the larger companies are having the same problem now. So now I'm going to talk about our use case, the product that we're working on right now. And I'm going to talk about most of the failures we've had. But anyway, so this year's project that we just finished is on AI trust. So the idea was, and we're going to have a little bit of a preamble on this, is we wanted to develop with Oregon State a product to provide trust in AI. Now, when we started this project, we started this as sort of, one of these weekend efforts. And we called it the AI RMF. So our AI, Artificial Intelligence Risk Management Framework, was actually developed and launched in January of 2023. And of course, we got a trademark on that. We applied for the trademark in September 22. And in middle of September of 23, we got the registered trademark. And basically, you can see the scope of the trademark. And this is the scope of the app. We basically want to develop a AI app for risk-based problem solving and risk-based decision making. So this became my daughter's, she was graduating as a senior last year from Oregon State, and this became our project, our senior project. So instead of having a team, we only had one person working on it, her, and we developed an app. Now we couldn't develop an app. Why? Because the AI RMF is a standard. And it's a standard in the federal government that's become the hub for all AI regulation, for all AI guidance, for all AI, both de jure and de facto. So de facto means it's a guideline, best practices. De jure means this app, this standard is actually going to go into statute. So that's a little background on it. And you can see this is what we were trying to do. Basically, develop an app for risk-based decision making to provide assurance and trust for all AI. So this was a little bit of a global reach, but we thought we could have some fun with it, and we did. And that's what we're working on now, and that's what the rest of the talk is about. This is a little description of our project at Oregon State. So just a little background. The NIST AI RMF is a standard, actually guideline from the federal government. We in the US are about 5 years behind the Europeans in terms of AI assurance, AI trust. So we basically rushed this standard out, And we thought we would have some fun, and we have had some fun. We're still developing it, uh, basically developing a series of apps around this framework. And again, this framework we thought would be something that would be a throwaway, meaning nobody would pay attention to it. But because the federal government is slow to react to technology, they're slow to develop regulations and statutes. The feds, and especially the White House right now, has developed this framework as being the hub for all of their regulatory actions for every agency, for every type of AI product. So this is what we're trying to do. And you could see our description. So here are the pain points. Then the big pain point was very simple. And this, by the way, is the number one challenge for AI development, any type of product development, is the ability to establish trust. And unfortunately, it's really, we have the lack thereof. Now, trust is really another, from an engineering point of view or business point of view, trust is normally indicated or shown or proved through what we would call assurance, different types of assurance. So I'm going to spend, probably about 5 minutes providing context, and then I'm going to dive back into it because it's important to understand this particular element of why AI doesn't matter if you're dealing with almost, well, first of all, here we're talking about public-facing decision-making apps, but almost this area of trust applies to almost any type of product. Why? Because AI is going to be involved in decision-making from you're visiting a hospital to you're buying a house to having car insurance to having homeowners insurance. AI is going to be involved in decision-making, whether we like it or not, or whether we even know about it or not. It's going to be all over the place. So a little background on trust, and then I'll dive back into it. So I'm going to provide context for about 5 minutes. Let's take a look at policing. It's a social system. And again, trust is really a social system. Remember, AI involves two elements, the social piece and the technical piece. A big part of our failure developing AI products is really not understanding the social piece. Another way to say that is we don't understand the impacts, either immediate of our product or downstream. We don't understand the assumptions, and quite often, quite frankly, we do not understand how these AI systems work or how we can even glue them onto our products. The reality is they're going to be part of our lives for the next umpteen years, but we don't know. So here's a story, but it's a story that has a lot of implications and ramifications. Policing. So I'll give you the story, and I'm going to take it to an extreme. It could be an illogical extreme, but it's something that impacts every city. So Oakland is right outside of San Francisco. It's on the East Bay. And then by the way, very, very liberal city. Explosive growth in crime. We live in Portland, Oregon. Our murder rate now is 3x, 300% more than it was 4 years ago. Never in a million years would I have thought that I'd have to worry about going out at night. But the reality is, Oakland, probably the most liberal city in North America, was considering using lethal robots. This is an extreme of that. You have a robot, a dog, with a 20 millimeter or 50 caliber cannon on top of them. And here's the problem, the solution. There's no human in the middle. That's a problem with almost any type of AI. Quite often, there's no human in the middle to moderate, to assure, to provide trust in this autonomous decision making. In some cases, and we're going to talk about it, it can become lethal. So this is an example of what happened in Boston last week. I wouldn't think that cities would be using robots, but here we have Boston Dynamic robot that was actually shot at, and in in some cases it survived. The point is, and by the way, you can see the date on the bottom. It's March 27th, 24. Um, cities, even the most liberal cities, progressive cities, do not want to use robots. Fact is, crime is accelerating. People want safety, and nobody wants to be a police officer. We have a Delta. What's the solution? Automated systems. Now, the question is, what are these systems going to look like? And where's the human in the middle? We don't know. So here's something from Israel. They're using the same thing now, but with facial recognition. Now, keep that in mind because this issue of facial recognition is going to become more important in this narrative. In this case here, the Israelis, IDF, uh, Israeli Defense Force, basically arrest the wrong person. And this is what's happening at our border right now. And there's a lot of takeaways from that. We have a lot of people, migrants, rushing into the country. And by the way, they're doing that in Europe. They're doing that in Asia. This is from the New York Post and News Nation. But here's the problem. We have 8 million undocumented migrants. If Trump takes over, we're going to have a mass deportation of 8 million people. Now, is the fait accompli? I don't know. But the reality is, the Chinese are using AI. The Chinese are using facial recognition. And almost every law, this is very important, every law in US, Canada, Australia, in liberal democracies abhor facial recognition, saying you cannot use AI for facial recognition. The reality is, if Boston, Oakland, Portland, Oregon, which is where I live, keep on having these rates of violence on the streets, we're going to inevitably use some type of facial recognition. I hope we don't have robotic dogs with a 20 millimeter cannon on top of them, but the reality is we're moving in that direction very quickly. In Asia, they're already doing that. China, it's done. So here's another problem. The U.S. federal government does not and cannot come up with regulation. It's politics, it's a lot of stuff. So what's happening is that the states now are developing AI regulations. And this is what I was going to talk about in today's talk. But I thought it would be a little bit more important to have some fun, talk about our failed projects, and maybe introduce some new ideas. But the reality is, in the absence of federal regulation, the states are taking over. And the states, by the way, are coming up with disparate laws and regulations. And when you have a lot of variation, we should know that as quality, reliability professionals, what happens? We have lots of variation. We have lots of deficiencies. We have lots of confusion. We basically have uncertainty, unpredictability, and no trust. Again, the essence of quality is consistency. And risk and all that other stuff is the opposite. So here's an example. This is just from a week ago. Tennessee, that has a lot of creatives. They basically developed a law for musicians in AI. They call it the Elvis Act. Sort of interesting acronym. Ensuring Likeness, Voice, Image, and Security Act. And this is what's happening. You can see that from our little image here. So here's the problem. Every state is coming up with their own rules and regulations. Every country is doing the same. Every sector is coming up with their own AI regulations. There's no consistency. Again, consistency is the hallmark of quality. Hallmark of quality is the hallmark of assurance. The hallmark of assurance is high trust. What we have is uncertainty all over the place. And what happens is, again, now I'm going to go back to our app. How do we develop an app where we're trying to come up with a solution to countless pain points that are very diverse? And that's the challenge. So let's get back to the app and some of the ramifications. Our app is the AI RMF. It's for risk-based decision making. Why is it important? AI decision making, problem solving is all over the place. It's black box. It's unexplainable. Bias quite often gets baked in. The rules of human engagement, the rules of engagement, what we call between human and machine, are not defined. And the rules of engagement should involve trust, fairness, explainability, and assurance, transparency, a bunch of other words, but we don't have that. If we don't have that, we don't have trust. So here are the three key questions that any developer of AI system has to address. They're very simple questions, and I've addressed them before in talks, but I'm trying to show you how it involves design and deployment. There's what question? What standards are you going to design to? If you're building a nuclear plant, you've got the ASME code. If you're building a oil and gas facility, which I did for many years, you've got the API, ASTM, ANSI specs. Anyway, we have specifications. If you're developing pharmaceuticals, you have the FDA. Anyway, you get the idea. We don't have standards for doing AI design. Second, we don't have any standards for providing AI assurance. And again, AI assurance and accountability involve trust. Now, how do you basically establish a trust in a system, design system, that's unexplainable? That's a conundrum. We don't have an answer for that. And then finally, who should conduct these AI audits and assessments? That goes back to that second slide I showed to you. We were approved by the U.S. Department of Homeland Security, by the Secretary. Again, we were the only company approved. Now, AI is going to be baked in to every decision making in every type of product. And the question is, how are we going to deal with this? Again, any designer has to address these questions if they're going to build an AI system, especially if it's public facing, and if it's decision making or problem solving. Three questions: what, how, who. So I'll give you some of the solutions. And by the way, you can basically find these on the web or Google them. The USA has the AI Bill of Rights. There are 5 pieces to it. Its goal is to build safe systems. It's going to protect us from algorithmic discrimination. It focuses on data privacy. If there's a breach, all recipients have to be notified. And if has human impacts, meaning biased, there are alternatives, CAPAs, litigation. Anyway, that's our approach. The NIST standard, which is our app, is basically the how-to. This is basically, this standard has 2 elements to it. What are you going to assure against or adhere to? And 2, how are you going to do it? And this is the basis for our app. And as you can see from the right, there's 4 pieces to the app. Govern, map, manage, and measure. This basically is the framework that the feds are going to require every federal agency to do. So this is what we're doing in the US. The EU has a little bit of a different spin to it, and I'll spend a minute talking about it. The EU has the EU AI Act. basically 4 levels of risk. Now, that's an important takeaway. The prism, the lens, the taxonomy, the language of AI is through risk, meaning the AIRMF, our app, is a risk app. The federal regulations coming out of the president's office or out of OMB, all risk-based. The EU Act, all risk-based. So the EU Act, they're about 4 years ahead of us, has 4 elements, 4 areas of risk. And by the way, we have to incorporate this into our app. And again, this is a scoping issue. What do we address? How do we address it? How do we deal with those 3 questions that we just talked about in the previous slide? Very difficult. And this is another takeaway. If you're going to be developing an app, it's going to be dynamic. If it's dynamic, these are things that they do not teach you in school. You have to learn that. And by the way, these things are unwritten rules. And it takes a long time to learn them. So basically, the EU says, and this is what the US is going to do. If you've got level 2 systems that involve autonomous decision making, and examples are infrastructure, enforcement, employment, and here, by the way, all of them, all the areas that are in the 2 category. As you can see, infrastructure is a huge area. Number 6, law enforcement. Now, if you go back to the Act, unacceptable risk are risks to the safety of people. The Europeans explicitly 4 years ago said facial recognition cannot be used, except if there is a terrorist incident. But here's the reality. The technology is moving so fast that laws are taking so long to get on the books that industry, the commercial side, is just simply running amok. And they're basically incorporating facial recognition, even though it's explicitly excluded because it's a number 1 unacceptable risk. Countries, commercial companies are using it. So basically the law, let's look at number 6, law enforcement. And we talked about this, what's happening in Boston with the robotic dog. It's happening in Oakland. They're using facial recognition. Explicitly, it's not supposed to be used, but the fact is companies are using it. So here's another little interesting story. We just got this little notice from Apple. We've got this app, the AIRMF app. It's online. And we got this notice a week ago saying, industry codes or standards made under the Australian Open Safety Act may apply to you. Oh, by the way, you're on the hook. So we said, okay, well, we're paying a lot of money to Apple. Now, Apple does not make money from their hardware, the MacBook and MacBook Pros. They make money from app development. They make 30% of their gross revenue. 30%, if I sell $1 worth of my app, 30 cents goes directly to Apple. There are over 1 million apps. They make their revenue from app development. Right now, the U.S. government, Department of Justice, DOJ, is basically suing Apple for infringement and for class action. This could, by the way, be as big as DOJ going after IBM 40 years ago. Anyway, they're basically saying to me, an app developer, I have to comply with the Australian Online Safety Act, which essentially is an AI act. But I'm paying 30% of my revenue straight off the top, gross, to Apple to take care of this. And they're basically telling me now I'm on the hook for a global app. This is what's going to happen. U.S. government cannot come up with regulations for AI oversight. And what's happening is countries and states are developing their own requirements. Industry sectors are developing their own requirements. Quite often, they are de facto requirements, but they're still important for every developer to pay attention to. By the way, this little thing is the same little game that TikTok played. Basically, the House passed a law saying TikTok's got to do one of two things: sell itself or decouple from the Chinese Communist Party. So what they did is TikTok sent a little missive to their 170 million downloads in the US saying, go to your congressman and complain about it. Well, they did, and then now they're facing backlash. This is what Apple's trying to do. They're going to all the developers, including us, saying, hey, if you don't like what's going on in Australia, go to your congressman and say, hey, I want you to get off my back. I think this is a wrong approach, but the point is, from a developer's point of view, if you're developing an app or any type of product that involves AI and trust and decision making or problem solving, you've got to pay attention to what's happening globally, and you have to be able to answer those three questions: what, how, who. So here are questions that I've learned in product development. I'm running out of time, so I'm going to cover these rather briefly. Quality attributes on the left for a product, a static product, are measurable and designable. The ones on the left. And these are quality attributes that any engineer who has been in the business 5, 10 years knows. Every one of those attributes on the left are designable, explainable, measurable. Here's the problem. The ones on the right, AI attributes, are social technical attributes. They're hard to design for, they're hard to explain, they are hard to assure, they are hard to measure. How do you measure trustworthiness or fairness? Here are other lessons learned that we have, that I've had. There are changes, just like that message I got last week from Apple. Changes in international, national, state laws. You have to stay abreast of them. Quite often, there are no or few regulations. The pacing of industry is huge, is very, very fast for AI development, and there's very little policy or direction. There's a shift of liability going on too. It used to be a month ago, if I had my app on the Apple Store and I passed all these tests in test flight for my app, I'd have clear sailing. Nowadays, just last week, Apple is shifting the reliability onto me to comply with the Australian AI Act, or the equivalent. Other things, lessons learned. Open source or tailored LLMs are inherently dangerous. Many companies have open source large language models. They're great, but we don't know how they make the decisions. We don't know where they got their data from. So the solution for that, especially in terms of building trust and assurance, is what we call RAGs. I'm not going to spend any time on RAGs, acronym for Retrieval Augmented Generation. But if you use a RAG, you can answer those three questions: what, how, and who. Big question about biased data sets. For us, do we come up with one app, which right now we are, but it's going to be a mega app, almost a platform? Or do we come up with single apps or that we bundle together into a solution? Again, lots of questions, few answers. Issues of latency, issues of state management. Almost every app that you're going to design these days, AI app, is going to be dynamic. You're going to have to deal with things like latency, state management, regulations, governance, assurance. They don't teach these things in school. Now, if you're in a top 5 graduate program in AI, the first class you take is ethics, where all these issues of trust are taught to AI developers or AI leaders. But right now, as an undergraduate, in almost every program, it's not covered. Here's another takeaway that might offend a lot of you is if I'm looking for a consultant, for a design consultant, I would make sure that they had knowledge of how to incorporate AI into the app. And that basically means that, they should have been designing products, both hard, what we call static, and dynamic products in the last 3 years. This market has changed so much. The knowledge base has changed so much that, the old standards, whether you're using ASTM, ANSI, or whatever, IEC, are still applicable, but putting those into a product and integrating it and making sure it meets requirements, laws, has changed and changed dramatically. So where do you start? First of all, if you're just entering this market, get the NIST AI RMF. It's a free standard or guideline. It's pretty thunky, but it's free. Again, ISO 42001 is the ISO standards. They came out last month, cost you about $230. I would first, and by the way, that's 10 pages. The ISO 42001 is 10 pages, and then it's got 35 pages of filler around it. So it's about 45 pages in length, 50 pages. The critical piece is 10 pages long. You can get the AIRMF, which is 200 pages for free off the web. Second thing I would do is take this Coursera course. When we enrolled, there were 4,000 people. Now there's 1,200,000. Got 4.8 reviews. If you don't know AI, take this course. You can audit it for free. It's a great course. Basically gives you sort of the key language, the key words, key concepts in AI. Buy 42001. If you're in the quality reliability world, you can get it off ANSI, you can get it off ISO, you can get it off any CB, certification body. The guy who did the course on the right is Eng. He's one of the founders of Coursera. Take Eng's more advanced courses. I think in a previous talk, I talked about LLMs, where I needed 4 years of math, advanced calculus, vectors, linear, to go through the core LLM technology. Now you can take it online and it does it intuitively. Read our books on risk-based auditing. It's an assurance book. It's a little bit geeky, but it'll get you the idea. Additional resources for risk is go to this website. We've written a bunch of books. It's part of our family or ecosystem of AI. Here's our app. And the question I think you're going to have to ask is, are you going to be an AI doomer? Or are you going to be an AI boomer? The reality is it's not going to go away. And figure out what you're going to do with it in terms of your career, work, job, income, and employability. So anyway, thanks for your talk. I've got about 4 minutes to answer probably one question. Go ahead, Fred.
All right. Well, I hadn't seen any during the presentation, so if anybody's got a question or stuff, we can use the chat or the Q&A tab. All that good stuff. Let's see. So one of the questions I got for you, Greg, is you talked about APIs, pulling up from a database.
Mhm.
That's not AI, right? That's just an interface to a database.
It's
If
also
that-
it's also the interface to the AI system.
Like if you were connecting to ChatGPT, for example, and you sent them a question from your app and then you got that answer and presented it back out, isn't that that's just using Chat GPT? It's not making a decision for you, or is AI in an app when it says turn left now and controls your steering wheel? Or is it, here's a nice picture for you?
So let's sort of take some terms. GPTs in general are largely, they're based on an active system, but what they do is they just simply provide an answer. The next phase to that are called agents, where they can make autonomous decision making.
Well, what's an example of that?
An example of an agent would be I have a home system. I come home, or it basically raises the temperature of the home within a range. That's a decision-making system. It's autonomous and it makes a decision.
Well, I mean, we've
That
had
would
that
be
for
an agent.
years though, where I don't think there's any AI in it. It's like a simple on-off switch. If my iPhone gets close enough to the house, it says turn the stairway lights on and change the heat. We can automate that. I have lights in the house that are controlled by the time of sunset. That's that's not AI in my mind. That's simple programming. It's not dynamic at all. It's just smart saying, oh, sunset's different today, so we'll turn the lights on at a different time.
Yes, and that's one of the problems that we have is we don't have a taxonomy of what AI is. So what we do when we go to a system is we say, is it proactive? Meaning, can the system, AI system, make decisions on its own?
So
Then I say,
instead of me programming, essentially turn these lights on at 10 minutes before sunset, it does it all by itself because it's watching my pattern in the house.
yes, the pattern of behavior. The second thing we would look at would be, is it preventive? The third thing we would ask is it predictive? And then the fourth thing we'd ask for is the system preemptive. And the question is, what type of preemptive decision making is it? Does it have access to nuclear codes or to the rods in a nuclear plant, or is it or turning a valve in a water facility? You know, again, a lot of this stuff is context based for its decision making, and
Yeah,
teaching an AI system context is right now one of the bleeding edges of AI.
right. See, I've worked with companies decades ago that, we're working on, it's a safety system in a chemical plant, for example. And one of the things would be they'd have a pressure vessel and they had a various set of sensors that said, this is going to be too much pressure and we're going to shut down the system. And it had to be directly programmed to, I got this trigger, this trigger, this trigger, shut it down. And it does it very, very fast. The decision making is built into Fortran or whatever language they were using, right? It wasn't an unknown problem where it was, we don't know if this pressure vessel and the set of systems are going to cause it to explode. We know it explicitly. We can measure this, we can see the trends, and if a human could do it fast enough, a human could do it. But that's not AI.
Part of it is the definition of what AI is. So normally I'll say public facing, autonomous decision making, that obviously public facing means it impacts people. So, you're going through a credit check for a house, you're buying a car, you're living in an area of California with high risk or right next to an earthquake. These systems make decisions for the entire area or for the entire population. So part of it is scoping out the system. What are the assumptions? Who are the stakeholders? Meaning context.
Okay. Well, I'm not seeing any questions. It looks like a few people are heading off to their next meetings and stuff. I think we'll call it a wrap.
Okay.
And we'll get the recording up in a day or two. Usually takes a little while for me to get it all sorted out. What do we got next week or next month, Greg? You put
What do we have? I have, I g-
so
um,
besides the slide deck, title abstract for next month.
yeah, what do you want me to talk about?
I don't know.
Uh, techie talk?
I don't know, something the audience can use and be practical about applying.
Okay, let me do an update on the ISO 42001 came out about a month ago. I can talk about that. I haven't talked about that for a while. I
Okay,
can do that one.
okay.
You know, it's a fun ISO talk. Okay, anything else?
Got Jacob just dropped a question here. Could you explain a little bit regarding the categorization of functionality of AI? There are multiple functions where AI either enhances, controls, or outputs features, AI generated picture for one. Regarding the categorization of functionality of AI.
Yeah. So remember that slide that I shared with you on the left were the quality attributes, on the right were the AI attributes? And I said, you know, the quality attributes, everyone is measurable, explainable, blah, blah, blah. The ones that are on the right are not explainable to a large and measurable. That's an example of those quality attributes. It's very critical to define those attributes so they can be measurable or assurable. That's this, maybe that's another talk.
Yeah, yeah. Add that to the list.